My name is Justin Sung. I'm a team lead at Adobe's Ad Cloud engineering division, and I'm here today to tell you about our journey implementing CI/CD with Bazel. Like most engineering organizations, Adobe Ad Cloud reached a position where it needed to meet ever-growing demand of rapid business value delivery. The organization wanted more frequent releases, faster turnaround times for features and patches, and ultimately, faster delivery of value to end users. However, common frustrations, such as long build times and unreliable tests, individually seemed manageable, but in aggregate, impeded progress. No resolution targeted at specific frustrations granted meaningful improvements. Hence, the approach shifted toward identifying fundamental underlying issues made manifest in aforementioned frustrations. Ultimately, it decided to adopt and implement a well-known engineering paradigm, CI/CD. Prior to CI/CD, each of our many services on which our developers worked on had its own repository, Maven build and deploy pipelines, and dependency tree. Monorepo code consolidation reduced build fragmentation. Build times increased, however, because our build system, Maven, did not have incremental builds. These builds could take hours. Deploy pipeline fragmentation led to complex environment deployments requiring extensive human coordination. Such circumstances made automated end-to-end tests prohibitively expensive to write. They also made releases complicated rituals, with large checklists and many participants. These releases, replete with human error, became time-consuming and infrequent rituals. Instead, AdCloud wanted a simple development process. Developers push PRs, triggering builds and validation with both unit integration tests. PR merges with approval create GitOps-generated deploy PRs. Each PR corresponds to an environment, production, staging, etc., and contains a Kubernetes manifest of change services to deploy. Merging a deploy PR promotes changes to the targeted environment. This minimal amount of human coordination and hence increase in developer efficiency became one of the driving motivations for our Bazel-based CI pipeline. We also wanted the pipeline to execute quickly, with fast builds, automated tests, and simple dependency management. Lastly, we wanted frictionless rollouts. Using declarative deployments to Kubernetes would provide traceability. The implementation of this process starts with a relatively straightforward build process, literally Bazel build and Bazel test. Bazel here gives us two notable advantages. Firstly, incremental builds and tests keep execution time low. Secondly, Bazel's reproducible builds generate content-addressable images, for example, SHA-256 image names, which end up in our Kubernetes manifests. With the images, the pipeline can proceed to set up GitOps deployments, using Kustomize to create manifests. It will also create deploy PRs, render manifests into the code repository, and push images. Lastly, when a deploy PR merges, a watcher pulls the code repository and renders those manifests. Now, the implementation first starts with binaries, which then become container images. Kustomize then creates manifests. Next, a custom Bazel rule called rules GitOps creates deploy PRs, renders manifests into the code repository, then pushes those images. Notably, because the image hashes only change with content changes, the PR will only have updates to modified images. Also, because the code repository stores render manifests by namespace, one single pipeline suffices, and this custom rule has since been open sourced. To illustrate the practical usage of this, let us first consider two teams. They both have some number of services deployed simultaneously to some namespace. Team 1 first introduces a change to Service 2. This in turn updates Service 2's GitOps targets and creates deploy PRs for configured environments. Team 1 decides to deploy to dev by merging the dev deploy PR. The other deploy PRs remain open. Now, Team 1 updates Service 1. Service 1 now has updated GitOps targets. Service 2 remains unchanged. A new dev deploy PR is now open, and the other deploy PRs receive new commits with Service 1's manifest changes. Team 1 deploys both dev and stage by merging those respective PRs. The prod deploy PR remains open. Now Team 2, which has been quiet so far, updates Service 4. Service 4 gets GitOps targets, and Team 2 sees deploy PRs for its environments. Since Team 1 and Team 2 have their own namespaces, their deploy PRs do not overlap. The developer's interaction model with the pipeline represents a radical departure from orthodox build and deploy pipelines. Classically, each deployable has its own build, test, and deploy pipeline, and promoting changes into environments requires coordinating multiple deployables pipelines. Our model obviates all of that and instead presents a single, simple question to the developer. Which namespace should receive the latest update? Everything else is already handled. and rollout of this CI/CD process provided useful lessons for the future. Firstly, while we expected quality of life improvements, they proved far greater than anticipated. Stories of teams eagerly ditching their 2-hour builds regaled our ears. Additionally, rollout demonstrated the need for constant and active communication to help developers understand this new build and deploy model. While they understood CI/CD, many had grown accustomed to pipelines with high user interactions and thus needed hands-on onboarding. Now fully implemented and rolled out to Ad Cloud's 200 engineers, the CI/CD pipeline allows developers to push their changes to environments quickly with minimal intervention. Post-PR merge, the pipeline handles builds, runs about 2,000 tests, registers artifacts, and handles deployment marshalling. The developer interacts with the system only once to identify and merge the deploy PR corresponding to the desired environment. This entire process takes roughly 10 minutes and at most 30 minutes. Thank you very much for listening. If you too are looking at implementing CI/CD with Bazel using GitOps deployments, feel free to check out our open source project called Rules GitOps.